Hi, and welcome back to Peak Flicks. This is Math, Grade 5, and I'm Mrs. Rossi. Thanks for joining us once again. So today, what we're going to be learning about is how to create fractions, equivalent fractions, in order to solve problems. Okay? Some of you might be a little intimidated by fractions until you understand how they're used to show parts of a unit. Sometimes we use fractions in everyday things, using time, in measurement for cooking, and also measurement for construction, and also when we go shopping. Let's say there is a third off or a half off sale, we're using fractions for that. So some questions to think about for today. Today, I want you to understand what are equivalent fractions and how do you create them? What does number one have to do with it? And how can I create one in fractions? And how do I know if I need to multiply or divide? This will come up a little bit later on. And I want you to be thinking about any other questions that you have that you could ask a family member or a friend for help. Let's keep moving. So here we have some examples of fractions. So you can see we have unit fractions, and what unit fractions are fractions that have 1 in the numerator, or 1 on the top. So this is 1/2, 1/3, and 1/4. They are also proper fractions. Proper fractions are any fractions that have a lower numerator than denominator. The numerator is the top number and the denominator is the bottom. The numerator is the part and the denominator is the whole. Sometimes we also have improper fractions. And improper just means that the numerator is higher than the denominator and can be made into a mixed number. And so that's our next thing that we have. A mixed number. A mixed number is really just a mixture of a whole number, like 2 in this case, and a fraction, which is a half in this case. And what we're going to be doing today is finding equivalent fractions. So an equivalent fraction could be 1/2 is the same thing or equal to 2/4. So if you're thinking about a piece of a pie, and if you split it in half, there's 2 halves, one on each side. But if you split each of those halves across in the middle, there will be on one side it will be 2 out of 4, and it's the exact same thing as 1/2. You've just made another cut. All right, so let's move on to our real work of the day. We're going to be finding some equivalent fractions, and then we're going to be doing some word problems with equivalent fractions as well. You have been doing such a great job. We're going to keep moving forward. We're going to start out with a little fluency and then get on with the day's work. Have some fun, take a little break, make sure your pencil and your paper or your whiteboard and marker are working properly. And if you're on the computer, make sure you're fully charged or plugged in. I'll see you back here in just a bit. How fast can you be? Can you beat me? Today we're going to be dividing by the number 6. I hope you're ready. Let's get started. 42 divided by 6 is equal to, that's right, it's 7. 54 divided by 6 is equal to, if you said 9, you are correct. 12 divided by 6. My friends, that is equal to 2. 60 divided by 6 is equal to 10. Let's keep moving. 0 divided by 6 is equal to, big egg, 0. 66 divided by 6 is equal to, if you said 11, you're correct. 30 divided by 6 is equal to 5. 48 divided by 6 is equal to, it's 8. 6 divided by 6 is equal to 1. 72 divided by 6 is equal to, I'll give you a little bit longer for this one. I hope you said 12 because that is the correct answer. 18 divided by 6, that's equal to 3. 36 divided by 6 is equal to the same amount of light bulbs that's on this page. The answer is 6. 24 divided by 6 is equal to 4. How fast are you? You can practice on your own by going on Reflex Math or by using flashcards. You have been doing such a great job and you are getting better and better every day. Continue to work hard and join us for the next part, which we are going to be making equivalent fractions. I'll see you in a little bit. Okay, so our learning goal today is to make equivalent fractions by finding the greatest common factor. Okay? The greatest common factor can be found by listing the multiples of the numbers that you're trying to reduce in your fraction. So the example that's on the screen is between 36 and 18, and we're using a T-chart. So a T-chart just basically will tell you which factors multiplied by each other will equal that top number. So 1 times 18, 2 times 9, 3 times 6, those are all for 18. And then we also have for 36, we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And so I've already highlighted the 18 because that will be the greatest common factor. So if I want to reduce a fraction that has 18 in the numerator and 36 in the denominator, I will use 18 to do that. All right. So making equivalent fractions is basically the same thing as like if you wanted to look pictorially, at the top we have these red bars for 1/2. Okay. I've also circled 2 of the fourths because those are the same size as the 1/2. And 3 of the pieces of 1/6 would equal 1/2. And also 1, 2, 3, 4 of the 1/8 pieces or 4/8 would equal also 1/2. There's a couple of examples that are listed over here. And the greatest common factor, I'm going to show you how to do in a T-chart on the side paper. But for right now, I'm going to just show you what those greatest common factors are. So the greatest common factor for 3 and 9 ends up being 3. 3 can be divided into 3 and to 9. The greatest common factor for 3 and 33 is also 3. The greatest common factor for 7/21 is 7. And what's interesting about all 3 of these is that all 3 of these numbers are prime numbers, which have factors of only 1 in themselves, so that makes it a little bit easier. And we have 8/80ths, which is a little bit more tricky, but the greatest common factor ends up being 8, because 8 times 10 is 80. Okay, I'm going to reveal to you the answers as soon as you watch the video on how to reduce these using this greatest common factor. Okay, so I'm going to get us started with reducing these fractions. Our first example is 3/9. So in order to start this, I'm going to list the factors of 3 and factors of 9. I like to do this on a T-chart over kind of on the side, where I will list all of the factors. So 3 is actually a prime number, and a prime number means it has factors of 1 in itself. So it only has 1 and 3. And actually 9 doesn't have too many factors. It has 1 and 3 and 9. The only ways to make 9 by multiplying is 1 times 9 or 3 times 3. It's not necessary to put 3 twice because I already have it once. And so this is my greatest common factor here, which is 3. So what am I going to do with that? I'm going to turn the 3's into a 1. And the way that I do that in fractions is if I put a number over itself, it's really just dividing. And so I'm going to divide by 3 over 3, which is essentially the same thing as dividing by 1. So sometimes you might see teachers do this. It kind of looks like a 1 giant 1, and that's exactly what we're doing, dividing by 1. So whatever I do to the numerator, I also am doing to the denominator in this case. So 3 divided by 3 is 1. 9 divided by 3 is 3. So my equivalent fraction to 3/9 is 1/3. And I can also check to make sure that my work is correct by doing something called cross multiplication. And that will prove that my fractions are equivalent. So I can do that. This 3/9, and I can times it by 1/3 if I cross multiply. 9 times 1 is 9. 3 times 3 is 9. And if these two numbers are the same, then they are in fact equivalent fractions. Okay, let's move on to my second example, which is 33. Again, this is not going to be too difficult to list the factors. I'll again put it in my t-chart. Again, 3 is a prime number, so I just have 1 and 3. And for 33, I have 1 and 33, and I have 3 and 11, and I believe that's it. So my greatest common factor again in this case would be the 3's. So I'm going to turn those 2 3's into a 1, or 3 over 3. So let me divide by 3 over 3. Again, I'm really dividing by 1, and if I divide by 1, I get the same thing. 3 divided by 3 is 1. 33 divided by 3 is 11. So I can tell you that 3/33 is equivalent to 1 over 11. And again, I can prove that to you by doing cross multiplication. 3/33 is equal to 1/11, and I can cross multiply that and get 33 over here. And I get 33 over here, so I'm pretty good with that. Let's continue to move on to our next problem. So the next problem is 7 over 21. And I know 7 is a prime number, so that's going to make it pretty easy to list the factors once again. So I'll put my 7 on this side and my 21 on this side. The factors of 7 are 1 and 7. And the factors of 21 are 1 and 21 and 3 and 7. So you might notice that I put some space in between. I have a lot of practice, so I know which order it will go in. You might want to put them in order after you've listed all of them. I'm going to just do it this way for right now. My greatest common factor here is 7. So I'm going to divide by 7 over 7. Again, it's the same practice, which is the same thing as 1. And I'll divide 7 divided by 7 is equal to 1. 21 divided by 7 is equal to 3. So 7 21st is equal to 1/3. And again, if I want to check my work, I can multiply the 21 times 1 and get 21, and the 7 times the 3 and get 21, and they are in fact equal. One other problem that I have to go over with you is 8/80ths. If I want to reduce that, I'm going to show you what happens if you didn't find the greatest common factor, but you knew they were both even numbers. So I'm going to divide by 2 over 2. Okay. 8 divided by 2 is equal to 4. 80 divided by 2 is equal to 40. Now you can see I still have even numbers here. I have 4 and 40. So what I can do again is I can divide another time. So my factors of 4 and 40, I could also do 2 again because they're both even numbers. So let me go ahead and do that. And I have 4 divided by 2, and that gives me 2. 40 divided by 2, that gives me 20. And I'm down to 2/20ths. That means I can still reduce further. So I'm going to rewrite my 2/20ths here, and I'm going to divide again by 2. And I have 2 divided by 2 is equal to 1. 20 divided by 2 is equal to 10. So 1/10 is the same thing as 8/80ths. So I can put that over here. I can test that out by multiplying. 10 times 8 is 80. 1 times 80 is 80. I hope you can see that instead of doing this repeated thing, which is dividing by 2 halves, divided by 2 halves, divided by 2 halves, instead of doing it 3 times, if I find the greatest common factor, it will be a little bit less work for me. So I'm going to go ahead and show you how to find the greatest factor of 8 and 80. I'm going to do that right here on the bottom of my paper. I'm going to show you one other way because I'm running out of space over here. You can also do a side t-chart like this. Okay, so I have 1 and 8, and I have 2 and 4, and that is all my factors for 8. For 80, I have 1 and 80. I have 2 and 40. 3, 4, I have 4 times 20, and that is all of them. Oh, I forgot. 8 and 10. So I have to squeeze that in here. I can put it over here. 8 and 10. So in this case, my greatest common factor is in fact 8. And I can also tell what the greatest common factor is after I've done all this work if I multiply these all together. So 2 times 2 is 4, and 4 times 2 is 8, and that's what I'm going to be dividing by. Okay, now that you've seen these examples being done for you, I'm just going to reveal the answer here. So 3 9ths is equivalent to 1/3. 3 33rds is equivalent to 1 11th. 7 21sts is equal to 1/3. And 8 80ths is equal to 1/10. Okay? If you need to go back and rewatch the video at any point to understand how to reduce these fractions, please don't hesitate to do so. Okay, for our question that we're going to work on together today is about our friend Cassie. So Cassie hopes to visit all 50 of the United States, or the US states. So far, she has visited 3/10 of the states. How many states has she visited? Explain your thinking and include a statement of the solution. Now, this sounds kind of tricky, but I'm going to show you a way that you can solve this problem fairly easily. What's nice about this is that this question has pretty friendly numbers. So I'm looking at the number 50 and the numbers 3/10. So what I'm going to actually do is set up equivalent fractions that I can find out how many states she visited. So stick with me. I'm going to show you on a side paper those numbers and how you are going to arrive at your answer. And I will explain my thinking, and I will explain my statement of solution as well. So stay with me for that one. And then we'll be back to read the question that you're going to be working on your own, and then I will take you through that. All right, so I'm trying to figure out how many states Cassie has visited. So it says she's been to 3/10 of all of the states. So 3 out of 10, that's the part versus the whole. And so down here, I have put 3/10 is equal to some number over 50. Because I know that 50 is the whole or the total number of states, and she's been to 3/10 of them. So in order for me to get an equivalent fraction, I need to find out what number can I multiply by 3 and 10 in order to get an equivalent fraction that has a denominator of 50. So think about it. 10 times what number would give me 50? And that's the number that I'm going to actually multiply by the same numerator and the denominator to get my answer. So 10 times what number is going to give me 50? And if you said 5, you are correct. So we are going to multiply the 3/10 times 5 over 5. And we learned earlier that we're really multiplying by 1, right? So 10 times 5 is equal to 50. Now I'm going to do to the numerator 3 times 5 and get 15. So if I were to write this up, I would say Cassie has visited 15 of the 50 U.S. states. I know this because 3/10 is equal to 15/50ths. And I'm pretty much good with that. So Cassie has visited 15 of the 50 US states. I know this because 3/10 is equal to 15/50ths, excuse me. And if I want to show that just to be sure, I can do my cross multiplication of my 3/10 is equal to 15/50ths. And if I cross multiply them, 10 times 15 is equal to 150. 50 times 3 is also equal to 150. So I'm very satisfied with this as my answer. Okay. So I'm so glad that you learned that Cassie was able to visit so many states. So let's move on to our next question that you are going to be trying on your own. Here it is. Stefan. This problem is very similar to the previous one, and I'm sure you're going to find success in solving it. Stefan has tried 7/10 of the 30 different sandwich toppings at Baisley's Deli. How many sandwich toppings has Stefan tried? Explain your thinking and include a statement of the solution. So now is the time where you're going to pause your video, try to solve the problem on your own, and when you are ready, you are going to unpause the video and watch me explain how to do the problem. That's it for right now. Put on your thinking caps and pause that video, and we'll take you through in just a bit. For this next question, I'm talking about Stefan. And Stefan has eaten 7/10 of all of the toppings at Baisley's Deli. Now, Baisley's Deli, we know, has a total of 30 toppings. So I'm going to set this up the same way as I've set up Cassie's problem. That 7/10 is equal to some number over 30. Okay? So in this case, I'm increasing my number, or my denominator, and also my numerator too. 10 times something will give me 30. What number am I going to put there? If you said 3, you're correct. So I'm going to multiply by 3/3, because that's essentially multiplying by 1. 3 over 3, or 3 divided by 3 is in fact 1. So 10 times 3 is equal to 30. And I have to do the same thing to the top. 7 times 3 is going to give me 21. So if I was going to explain my answer, I would say Stefan has tried 21 of the toppings at Baisley's Deli. Okay, I will also show you, to prove my answer, 7/10 is equal to 21/30. Okay, and I can cross multiply. 21 times 10 would give me 210, and 7 times 30 would also give me 210. So 7/10 is equivalent to 21/30. So I know that 21 of the toppings at Baisley's Deli were tried by my friends. All right, you have done a wonderful job. Please stay with us for some closing remarks, and I will see you again very soon. Have a wonderful day and kiss your brain. All right, PeakFlix math scholars, you have done an incredible job today. But you're not done yet. I'm going to need you to go on to Xerm, Reflex Math, or most importantly, fill out an exit ticket for today's work. Please show us how smart you are and what you have learned from doing the lessons here on PeakFlix. Thank you so much for your time, and we look forward to seeing you tomorrow. Have a great day. It was wonderful teaching and learning alongside of you. Take care.